Howdy folks, and welcome back for some more of section 3.2. So now we're going to get into the second half, which is more of the applications of standard deviation. Now, the first thing we're going to look at, though, is another term that is important in other textbooks and other courses. In this course, I'm not going to focus on it too much, but it is something that you should be aware of, and I believe they do ask you about it in the homework, so you want to make sure you're aware of what it is. And it's called the variance. So the variance of a set of values is a measure of variation equal to the square of the standard deviation. So it's very quick to find. If you have the standard deviation, you've calculated it, all you have to do is basically go back to the previous step before you square rooted it, and that is the variance. Like I said, I'm not going to get into the details about what it's actually measuring and whatnot, but it is an important feature when you're doing some analysis. So be aware of it when you're asked about it in the homework. So S squared, and then of course the symbol for the population standard deviation is sigma, but variance would be sigma squared. So now we have all of these different notations. So now the next part of this is the range rule of thumb. This is a pretty important one that's used in statistics quite a bit, and there's two layers to it. So the first layer is identifying significant, or in some textbooks they'll say unusual values. So basically what you're doing is finding two cutoffs for where the significant values end and where the non-significant values begin. So if we informally define significant values as values of a data set that fall beyond 2 standard deviations of their mean, then we can use the following formulas to determine if values are unusual, which means that they're either significantly low or significantly high, or usual, so they're not significant. So in words, you can kind of see what we got going on here. We have the mean minus 2 times the standard deviation or lower, the mean plus 2 standard deviations or higher, and then not significant is between the minimum significant and the maximum significant. So in symbols, we got our different notations. We got our x bar minus 2s, x bar plus 2s, and then we got mu minus 2 sigma and mu plus 2 sigma. So we're going to see that in action more as we go throughout the course. So if you're not quite sure what's going on yet, you're going to see what I mean in the next example. So let me just go through the second part of the range rule of thumb, which is estimating the value of a standard deviation. And we can approximate the standard deviation by taking the range and dividing by 4. So really it's a spin-off of the previous one. So let me just kind of give you a visual so you can kind of see what I'm talking about here. Let's draw a number line, and specifically we're going to want the mean in the middle. So let's say x bar is in the middle. Now we're going to have some data that kind of does something. You know, we don't have a bell-shaped curve, but we got something that goes like this. So that's hard to see. So let me just shut that light off. That's a little better, right? Okay. So now what's the standard deviation? We said before that it's the average distance away. So in this case, they're looking at 2 standard deviations. So if we said, okay, let's go 1 standard deviation, let's go another standard deviation. So there's S, there's S. So here's x bar plus S, x bar plus 2S. Same thing on the other side. So you got 1 standard deviation, you got 2 standard deviations. And so this is x bar minus S, and this is x bar minus 2S. So now, again, you might have some outliers that are beyond that cutoff, and a little bit of data beyond this cutoff, but that's okay. Those are more than likely outliers. But the bulk of the data should be in this range from x bar minus 2s to x bar plus 2s. So, and then how many standard deviations do you see in here? 1, 2, 3, 4. So if the data is typically within here, that's the range. So that's where they get this formula from. They take the range and divide it by 4, and that approximately is 1 standard deviation. So, Okay, so let's see it in action. Heights of men have a mean of 69 inches and a standard deviation of 2.5 inches. Determine what values represent two standard deviations from the mean. Classify 68.6 inches, 63.1 inches, 75.1 inches as significantly low, significantly high, or not significant. All right, so let's do the calculations. So we need x bar minus 2s, and that's going to give me 69.0 minus 2 times 2.5. So 69 minus 5, which is 64. And then x bar plus 2s, you can see. So again, now we're adding 5 essentially. So that's going to give me 74.0. So basically that's the cutoffs for significant values. So anything small, smaller than the smallest, or larger than the largest are going to be significant, but anything in between is not. So if we wanted to classify 68.6 inches, what would you classify that as? Which one of those three categories? Significantly low, high, or non-significant? Hopefully, you're saying that it's not significant. And the reason why is because it's right smack dab in the middle between these two numbers. So this is not significant because, and you can use inequalities to show it. So we can say 64 is less than 68.6 is less than 74. Boom, done. The other ones, 63.1 inches. Well, now if we compare it to our smallest, it's smaller than it. If it's smaller than it, then it's outside of that middle interval that we're looking at. So this would be significantly low. And again, because 63.1 is less than 64. And then I didn't give myself a lot of room, but 75.1 inches, you can guess is significantly high. And again, because 75.1 is greater than the maximum of 74.0. So that's kind of what we're looking at. It's just kind of classifying it into one of those three buckets. So, you know, and you can do that with any set of data when you have the mean and standard deviation. All right, we're going to see more of that type of analysis as we go. So, looking at example 5 now, it says, as of this writing, all the ages of winners of the Miss America pageant are between 18 years and 24 years. Estimate the standard deviation of those ages. All right, so they just want you to use the second part of the range rule of thumb. So we got S is approximately equal to the range over 4. So the range is going to be 24 minus 18 all over 4. So 6 over 4 or 1.5. So 1.5 years is approximately going to be the standard deviation. So when we're doing the actual calculations, we can kind of know if we're on the right track based off of this estimate. So I mean, if we're way off in our calculations, this will tell us that. So again, it's just to kind of check that you're in the ballpark. So, okay, so let's stop there, and then we'll pick up the next part, which gets into some special distributions and how we can analyze those more explicitly. All right, see you soon.